A shell is fired from a cannon with a velocity v meters per second at an angle theta with the horizontal direction. At the highest point in its path, it explodes into two pieces of equal mass. One of the pieces retraces its path to the cannon. The speed in meters per second of the other piece immediately after the collision is 3v cos theta, 2v cos theta, 3 by 2 v cos theta, root of 3 by 2 into v cos theta. This particular framework of problem is very popular or very frequently asked in the competitive exams. Okay, the principle underlined or the principle at work here is momentum conservation. Now, why will the linear momentum be conserved here? Look, they are saying that a shell is going to explode into two pieces. Now, is explosion an external force? No, explosion is an internal force. Okay, explosion is not an external force, it is an internal force. So no matter how large the internal force is, momentum will always get conserved, because Newton's second law of motion tells us that as long as the vector sum of external forces is equal to 0, momentum is conserved. Do you agree to this?
Yes, sir.
So that explosion thing is important. That says that it is an internal force and that leads to momentum conservation. Those are the two important points. Okay, fine. Now what is the initial momentum? Initial momentum pi bar is, okay, now at the top, okay, at the top before the collision, initial momentum, it will be m v cos theta I cap. Why will this not have any y component? Because the projectile splits into two parts at the highest point. And because it peaks at the highest point, we know at the highest point vertical component of velocity is 0. And so is the momentum. Do you get this?
Yes, sir.
Final momentum, post collision, PF bar. How can we calculate PF bar? One of the pieces retraces its path to the cannon. So we must have it as negative v cos theta as its initial velocity. What is its mass? Equal mass. Equal mass. So this will be m by 2 plus, okay, we still don't know the velocity of the other. Okay, so let us just call it m by 2 v bar. Anyways, we want to find the speed, right? So let's call it Tn. Okay, now applying momentum conservation. Okay, applying momentum conservation, what do we get? Applying conservation. Okay, applying momentum conservation. mv cos theta I cap equals negative m by 2 v cos theta I cap plus m by 2 v f bar. Okay, bring negative m by 2 v cos theta on this side, so that will make it 3m by 2 v cos theta I cap equal to m by 2 vf bar. Correct? M by 2 will get cancelled. M by 2 will get cancelled. Correct? So what will be the magnitude? 3v cos theta. Correct? The magnitude will be 3v cos theta. 3v cos theta.